everyone, this is Akanksha and today we'll solve word break problem of LeetCode. It's a new problem and the frequency of this problem is pretty good in interviews. It comes under medium category, but I would say it's really easy to understand if you know the concept of breadth first or depth first or dynamic programming or backtracking. So there are multiple solutions through which you can solve this problem. Um, so in this problem, we are given a string and we are given few words in the form of list. Now we have to determine using these words, can we form our string or not? If we can form them, then we'll return true. If not, then we'll return, then we'll return false. Now, in order to solve this question, I think I'll follow breadth first search. And the common thing about breadth first search is normally we use queue in order to, go through breadth first using iteration approach, not recursion. So let's see how to solve this. So first, we'll actually convert our list to set. And we can directly add all the elements of list to set using this. Now why we did this? So the time complexity of set, comparing or searching whether an element is present in the set or not is constant, while in list it's not constant, it's linear. So it's better to have set because we'll be continuously searching if our set contains a particular word or not. The other thing here is we'll have an integer array called visited, and that will be of size s.length. Now this particular array will keep track of all the indices that we have already checked through. So if you'll not use this, the LeetCode will complain about time limit exceed, and that I have already faced. So in order to improve our code and in order to maximize the time or minimize the time or optimize the time, we'll use the visited integer array. And last, for our breadth first search, we'll use queue. Now this queue will actually hold all the index through which we have to follow the search. For example, initially we haven't started our search and we are about to start. So the initial index that we'll be starting our search from will be 0, and that is for sure. So we'll add 0 to our queue. Now we'll save while my queue dot is empty. You can also use while my queue dot size is greater than 0. So while this is not true, I want to come in. Again, this is something that is being followed in all breadth first question. Now my start will be queue dot poll, which will be 0 initially because that is the particular index that I want to start my search from. So I'll first check if my visited of start is equal to 0, then only I want to proceed. If I've already visited this particular index, then I just don't want to proceed further and I want to go through or go to the second element in my queue. So for int end is equals to start plus 1, end is less than equal to s dot length, and end plus plus. Okay, so if my set dot contains s dot substring from start till end. So if this particular word is something that my set already have, so I can say queue dot add end because I want my next search to start from end, and I'll also check if my end is already equals to s dot length, then it means I already got my output and I'll return true. So this is good. If I don't get it, so I want to update my visited pointer here that I've already visited this particular index. So I'll assign it 1. Okay, this is good here. And if we haven't got our answer yet, so that means after this while loop, if our queue is empty, so we don't have any more solution and we'll return false. Pretty simple, right? I mean, what we did is we first initialized set and assigned all the elements of list to my set. Then I initialized this integer array because I want to keep track of all the visited indexes. Then I have initialized my queue, which will actually store the indexes from which I have to search my next word. So initially it will be 0. Then I'm following breadth first using while queue is empty. Then I'm polling and I know my start variable. First I'm checking whether my start index is already visited or not. If not, then we'll continue. I'll initialize my end and then it'll check and set whether I have this particular element or this particular word or not. If I have, then I'll add my next search index and I'll check for end. Let's see if this works. Oh, okay. Why did I do it string? It's integer, right? We'll be storing indexes to it. Okay, let's submit. Perfect. Pretty simple, right? So if I have to speak of this time complexity, I'll say the time complexity of this solution will be O of n square. Why n square? Because in the worst case, we'll actually be traversing through the entire string again and again for all its characters. So for all start, we are traversing through the entire string. So that is n square. And if I have to talk about the space complexity, then I'll say it's linear, that is O of n, because in worst case, maybe our queue will hold all the indexes of the string. So that is the length of string. So the space complexity is linear, that is O of n. Hope you like the video. If you do, do not forget to like and subscribe, and see you in the next.